All right, so this took me arguably longer than I would like to admit to figure out, but I thought I would share it now that I have it figured out. So I got a PC cooling kit. So this is a 12 volt computer closed loop cooling kit from Amazon on Black Friday. And so I wanted to hook it up to the CNC and use that as my pump. And that all worked fine. And now, because it's 12 volt, I needed to have a separate power supply. So you can see that power supply there. My wiring gets a little bit complicated and I do have to clean it up. But what I wanted to show is that with the super long board here, I'm using one of their 2 switch ports. So they have 4 auxiliary ports. 2 of them, I'll zoom in on it a little bit. 2 of them are switch ports that can take and turn on and off external power supply or external sources to a maximum of 24 volts by 1 amp is what can run through that circuit. So I have a 12 volt circuit. So I wasn't sure if I could even hook that up. But after looking at it a little bit and I just decided to ultimately test it, and it works. So what you can do in GSender and with the software is you can basically remap. So you can see aux output 1 trigger, and you can, aux output 0 trigger. So that's the 4 outputs, so 0, 1, 2, 3. And you can see that I've tied the aux output 0 trigger to the M3, M4. So that's for spindle on, spindle off. So I've got that set. So basically what happens now is that in GSender, there's my spindle. So I can activate the spindle. So there's the M3 G code command that'll be sent. There's my spindle. And there's the water pump. So when I send the M3 command now, the spindle spools up and starts running. And as well, you can see the flow meter on the pump and the pump itself. So the fans and the pump itself are now running and moving liquid through the system. So then when the job finishes and the software sends an M5, the spindle spins down and the pump turns off. And the pump turns off. So now when the job runs, that's fully automated. So that's pretty cool. So like I said, I tried that with a relay and a couple different things because I wasn't really sure if I should run 12 volts through the board when it was specifically calling out a 24 volt. So I was a little nervous about that, but figured I would just try it, and it did work. So my next goal is I've got the start of this over here. So this is going to be for an SSR. So I'm going to mount an SSR here and connect it to a plug, and that plug will run my vacuum. So that'll obviously be an SSR that goes to mains wiring, but gets its signal from the third, or I guess so this is 0, 1, and 2. So this is aux 2. So aux 2 and 3 are a little bit different. They actually send voltage down the line. So this will actually output a 24 volt signal, which will turn on the SSR. So when this goes active, and that being something I can tie to M7 or M8 for the mist or coolant, then I can basically turn on and off the vacuum with the coolant signal, which I think is going to be super fun. So then the shop vac and the water pump and the spindle are all integrated. They'll turn on and off with jobs and be super happy. So I'm very excited about that. So the last thing I do have is, unfortunately, I've got this temperature. Fortunately and unfortunately, I've got this temperature gauge that is hooked up to the flow meter. So this will give me the temperature of the coolant, but it runs off 5 volts. So I've got a voltage converter down there to give me 5 volts. Like I said, the wiring got a little bit more involved than I was maybe hoping, but I'm really happy with the expandability and functions of the super longboard and what you can do with it. So the other thing that I've done here just quickly is this splits off the 12 volt signal. And so coming out of here is multiple 12 volt rails, and I've put a 12 volt rail into the RGB power supply port on the super longboard. So what I can do is I can hook up a set of 12 volt LEDs to that port there, and they will essentially do status. They'll essentially work as status LEDs on the system. So what I think I'm going to do is mount a string of status LEDs on the under rail of the Ultimate Bee. So that'll be my next project now that I've got the pump working, and I think when the SSR arrives tomorrow or Tuesday from Amazon, I'll be able to get the vacuum wired up and should be able to get things moving. So the one thing I did want to double check is that when the pump runs, so we'll just turn this on. So spindle's running, pump's running, that the amperage we're drawing is 0.2. So I was kind of curious just how many amps at 12 volts this would draw. So currently I am pulling 0.2 amps on this. The pump is rated for up to 0.8, but obviously it seems to be moving and flowing just fine at 0.2. And as well, that includes the 2 fans. So I'm happy with that. And on to the next challenge. Okay, thanks.